A very good day to all the panel members. I am Aditya Guthivarekar and I am excited to introduce our next generation ship routing platform, leveraging cutting edge technology like NAV-IC based navigation, which is a satellite system launched by India, and AI driven weather forecasting, which uses data from the INCOIS API provided by the government. Our app is set to revolutionize maritime logistics by optimizing routes for efficiency, safety, and compliance. In this presentation, we are going to cover the idea approach, the unique features, and the showstoppers, and the UI snippets for the platform. So let's begin with the idea and approach. As we know, ocean is quite a dynamic environment. There may be varying tides, there may be varying weathers, there may be sudden increase in the air currents, etc., or there may be a piracy zone wherein the merchant ship might not be allowed. Considering the dynamic environment, a reinforcement learning model is the most suitable. We have used an AI agent-based reinforcement learning model. We ask the user's input, which mainly consists of the ship details like the propulsion system, the length of the draft of the ship, the type of cargo the ship is carrying. We also require the destination coordinates as well as the desired speed. Upon taking this, we contact the INCOIS API, which gives us the real-time updates on oceanic weather conditions. Via pre-processing, we then feed the data to the AI reinforcement learning model. The agent and the environment then collaborate and find the path which is having the maximum reward. The optimized path, which is sought by the AI, is then displayed on the dashboard using Folium, which is an open source library. The tech stack we are using is Python and Django for basic app creation, which is open source, SciPy for all the machine learning models, INCOIS for the API, that is the data of the ocean, Socket.io for the live transmission and notification, Chart.js for the data visualization part. Our system is also called as the Elevate system, wherein Elevate stands for Enhanced Logistical Efficiency via Advanced Tracking Engagement. Now, coming to the flowchart. The algorithm. How does reinforcement learning works? Now, before coming to that, I would like to shed some light on why reinforcement learning is better than other traditional models like Digital's algorithm. A route is what we require on a ship. It should be quite optimized, as well as the computational power required should be very low. This is the most suitable condition, and hence we apply the reinforcement learning algorithm. Reinforcement learning requires computationally less power and gives us more optimized routes. Now, coming to the algorithm, we start with the user's dashboard, wherein the user enters input parameters like air temperature, humidity, wind direction, wind speed, air pressure, rain gauge, long and short wave radiation. These are all gathered from the INCOIS API. Then the user enters starts and end longitudes and latitudes, the ship type and size, propulsion system, arrival time constraints, engine and hull condition, tidal data, cargo weight, ship range, and the most important part, the ship draft. Then the Q table is initialized. In layman's term, Q table is a table that consists of states of different parameters and different inputs. Before that, we should also remember that this problem is specific to the Indian subcontinent. Hence, a map of the grid-based map of the Indian Ocean is made. Now, after the initialization of Q table, we observe the state wherein each grid is allocated a reward or a random number in layman's term. After this, the reinforcement learning model, that is the agent, selects an action, which may be a change in course or a slight speed adjustment, etc. It takes the action, and upon that, it observes the post-action state, i.e. the reward. If the reward is found to be maximum, that means the optimized route is found, and that route is then displayed to the user dashboard via Folium, which is an open source library. Now, coming to features. The most important features in our platform are as follows. NAV-IC based precise regional navigation. NAV-IC is a satellite based navigation system launched by the Indian government and ISRO. So this is local to India, it is open source, and hence it is also quite precise. Real-time piracy zone avoidance alerts. As we know that there are many incidents of piracy near the region of Africa. Hence piracy zone avoidance alerts are must. Gagan enhanced GPS accuracy for course. Gagan is also a satellite constellation of India launched by ISRO, and hence Gagan provides precise regional navigation and exact accuracy. The most important thing is live traffic density visualization tool. We get the information of all the merchant vessel traffic in the Indian Ocean region, and hence we can plot their density diagram, which can also help the model to take the route which has less traffic. Emission and fuel optimization dashboard. Coming to emission is quite important. The UN SDG has set a target of reducing 70% emissions compared to the 2008 levels by 2035, and most of the emissions caused in our Earth are caused due to ships. As ships are a large part of our ecosystem, there are many number of ships, and they are always present anywhere and everywhere in the ocean. Ships therefore contribute to a large number of carbon dioxide released into the atmosphere. Hence, an emission and fuel optimization dashboard is a key feature. It also provides multiple routes optimizing fuel time and safety. For example, a ship might be carrying a hazardous cargo. Now, in this time, if let's say the algorithm only provides it to the most optimized path in terms of fuel, it can be compromised in terms of safety. But since it carries hazardous material, we provide it the optimized path in terms of safety as well. So the captain of the ship has a choice in which term or which factor it should consider while optimizing the route. Next is AI-driven route with weather forecasting. The Metrogram provides a prediction of the weather for 15 days ahead, through which we can derive the route. Then automatic EEDI and EEXI. EEDI and EEXI are two of the most important laws when it comes to maritime navigation, which we will cover in the next slide. Traffic separation schemes, real-time port congestion alerts. Traffic separation schemes is a scheme which is followed whenever the ship navigates inside the exclusive economic zone of the country. It is followed because there are a lot of shipping vessels or small trawlers in the country's water, and hence a traffic separation scheme should be followed. Real-time port congestion alerts. There might be certain congestions near big, huge ports such as JNPT, which is adjacent to the Mumbai and thus has the small trawler traffic of the Mumbai-based Gateway of India area. Hence, the port congestion alerts are quite important. For this alerts, we are using Socket.io, which is an open source library and can provide instant alerts. Crew feedback for adaptive navigation. Let's say the crew wants a halt or wants to anchor the ship for the night as it does not have a docking permission. Then such feedback can be incorporated into the algorithm, and the algorithm can then provide them an optimized routes. The last but the most important thing is routes can be split into waypoints. There are many waypoints while considering a route. Let's say from Mumbai to Visakhapatnam, there can be a number of waypoints, and waypoint is what are most important for navigators and merchant vessels, right? So the most important feature is routes that can be split into waypoint. Our algorithm takes waypoints into consideration as well. Now, coming to the key considerations for the algorithm, the number one key consideration will always be environmental impact. As I had mentioned, that the goal of the UNSDG is to cut down 70% of emissions from 2008 level by 2035. Environmental impact is our utmost concern. Second concern is fuel efficiency. Our routes are optimized based on fuel efficiency. Fuel and the burning of fossil fuels contributes to the emission of CO2 and thus the environmental impact. Hence, fuel efficiency is our utmost concern. Hydrodynamic performance. Now, for some ships that have been aging, hydrodynamic performance is a key concern. Their engine might not provide a constant output or constant acceleration. Hence, hydrodynamic performance should also be considered. Structural integrity. If, let's say, the route is passing through the waters which are high waves or high tides, it might affect the structural integrity of a ship. It might damage the hull of the ship. Hence, structural integrity is also a key consideration for our algorithm. Operational flexibility. As I mentioned, route can be split into waypoints such that the ships can be dock, port, or harbor, etc. Also, let's say if the ship wants to dock at a port, but due to some delay, unforeseen circumstances, there are some delays. So that delays can also be accommodated in our algorithm. And the most important factor is safety. Safety of the crew is utmost. Now coming to the feasibility. The feasibility of this platform is mentioned in 5 points. First, it requires robust data and resources, which is feasible since the INCOS API is provided by the government. Second, it integrates with real-time data systems. Third, it enhances operational responsiveness and efficiency of the organization. And centralized management is achievable now and integrates AI for accurate prediction. Hence, this platform is 100% feasible. Now coming to the showstoppers. Before that, I would ask you to kindly go through the UI snippets. The first UI snippet, we have a dashboard, route, fleet, and reports. Reports are the advanced reports which one can download, and this is the new route through which you can create a route. As you can see, this is the route from JNPT to Kandla, which is from Maharashtra to Gujarat. You can edit it as well. These are the route details. These are the route details that are the most important to the captain. That is arrival port, departure port, distance in nautical miles, the duration, optimal speed, which the vessel should be maintained at, then optimal fuel consumption, then estimated fuel cost, and route type, which is the great circle, and the last updated cost. Apart from this, the weather and sea conditions are also mentioned, wherein the current condition, wind and sea state, weather forecast, etc. is given, and you can see the vessel performance, current performance is given, and optimal performance is given. So the crew knows what is the measure of difference. You can download the exact report wherein the exact route and route charts are given as well. This is just an image for display purposes. Now coming to this part wherein a new word can be selected. It is the IMO number, then it is the vessel name, the vessel type, which type of cargo it is, the departure date, arrival date, departure port, arrival port, then the waypoints, you can add waypoints where you want to stop the vessel, then the cargo type and the cargo quantity in it, then the cargo unit, and also the optimized parameters. If you want to optimize based on speed, then what speed you require, enter consumption, what is the consumption, which is the threshold value for you, and the fuel type, it can be LPG, CNG, diesel, etc. and additional notes. Now coming to the impacts and benefits, first I will cover the showstopper. The most important showstopper is the dynamic. It is dynamic system and it provides real-time maritime charts. So charts are important for navigation and it provides a real-time maritime charts with updates on the dynamic conditions of the sea. Next important showstopper is digital logbooks. So as we know that in ship the compliance records are needed to be maintained and they are maintained in the physical logbooks signed by the crew. Here we provide digital logbooks for that. Then we analyze the vessel efficiency and vessel performance as we had shown in the UI snippets. The most important showstopper is the AIS, which is the automatic identification system for collision prevention and safety. It detects if there is any collision or a challenge to the structural integrity of the ship and accordingly alerts the crew. Next is it tracks compliance with regulation. It gives what regulations you follow, what laws have been violated, etc. Then the most important showstopper, which is crucial to the cargo, is tailor routes based on the type of cargo and specific requirements. A key example of this comes into picture. Let's say when I have a cargo which contains any acid that might change its molecular formula when it comes in contacts with water, or let's say when there is an increase in humidity. So we can optimize the route in a way such that the humidity is taken into the factor and the route is chosen where there is less humidity or less precipitation, so that the cargo remains intact and safe. Then the real-time updates on port congestion and delays. Let's say a ship is moving towards the port and there is sudden like accident or etc. which due to which a delay is caused. It also provides updates on that. And the last showstopper is the algorithm adjust for berth delays to ensure accurate scheduling. Let's say a ship which is currently docked does not have the accurate documents and hence it is undergoing some judicial action. It has been docked in the berth, so it might require 2 or 3 days. So our algorithm also takes into consideration the buffer period and then optimizes the speed and fuel according to that. Now, use cases. Firstly, it aligns with India's Sagarmala project. It is IMO compliant, that is International Maritime Organization compliant, eco-friendly voyages. It boosts the port connectivity and reduces delays, streamline logistics and cargoes, and avoid risks and ensure a secure travel. All of which are goals of India's Sagarmala project. Now, coming to the most important part of the algorithm, which are the laws and the regulation observed by the system and the algorithm. Now, the first law is International Safety Management (ISM) code. This code suggests all the safety precautions and guidelines that needs to be taken in a voyage. All of these are followed by the algorithm. Second is the safety of life at sea. Third is the Indian Coastal Regulation Zone (CRZ) notification 2011. Now, this notification is important in context to Indian subcontinent as there are a lot of areas in the Indian Ocean region that have been demarcated under the pretext of flora and fauna and corals. So these zones cannot, so ships cannot enter these zones, and it will be considered a violation. So all these zones are also considered by the algorithm, and hence the optimal route is found by taking this into consideration. Now, coming to the last point is Energy Efficiency Ship Index (EEXI) and Energy Efficiency Design Index (EEDI). So this is applied to ships with a specific cargo tonnage. That is why we ask the cargo tonnage in the as an input parameter itself. And whenever you have a cargo tonnage exceeding 2,000 to 20,000 tonnage, then around 2.7 to 3.0 gram of carbon dioxide is the threshold for the emission level, and hence the emission level should be below that. And this is also taken into consideration while by our algorithm while providing the optimal route. I thank you for your attention.